What's going on, everybody? Radio here, and we are back with another video. We've been talking about AI data centers for a good little while on this channel now, and I wanted to dig a little deeper on what is an AI data center. And it just so happens that there is an IBM article that explains exactly that. We also have a video from Good Morning America where they go into a Google data center. So hopefully by the end of this video, we're all a little more familiar with what goes on inside your average AI data center so that we're more aware and know a little bit about what the hell is going on. All right, let's get into it. What is an AI data center? By IBM, Alexander Jonker, Alice Gomstein. An AI data center is a facility that houses the specific IT infrastructure needed to train, deploy, and deliver AI applications and services. It has advanced compute, network, and storage architecture, and energy and cooling capabilities to handle AI workloads, we knew that. This is just a preamble, but thank you for letting us know. While traditional data centers contain many of the same components as an AI data center, their computing power and other IT infrastructure capabilities vary greatly. Organizations that want to capitalize on the benefit of AI technology would benefit from access to the necessary AI infrastructure. There are many routes to this access, and most businesses will not need to build their own AI data centers from the ground up. A monumental undertaking, you don't say. Options such as hybrid cloud and colocation have lowered the barrier to entry so that organizations of all sizes can reap the value of AI. Okay. So they're saying it's very expensive, but you wouldn't need to do it if you're a smaller company. You could just use half cloud, half real data center, or there's different options for different kinds of businesses. And I think this is what this article is aimed at. It's aimed at mostly businesses. AI data centers versus traditional data centers. AI data centers share many similarities with traditional data centers. They each contain hardware such as servers, storage systems, and networking equipment. Operators of both need to consider things such as security, reliability, availability, and energy efficiency. Well, I don't know about that last part. Between you and I don't know about that last part. I don't think they give a fuck about energy efficiency. They give a fuck about using as much energy as possible. So I guess that's efficient. The differences between these two kinds of data centers stem from the extraordinary demands of high-intensity AI workloads. In contrast to AI data centers, typical data centers contain infrastructure that would quickly be overwhelmed by AI workloads. AI-ready infrastructure is specially designed for the cloud, AI, and machine learning tasks. For example, conventional data centers are more likely to be designed for and contain central processing units, CPUs, whereas AI data centers require high-performance graphics processing units, GPUs, and their IT infrastructure considerations such as advanced storage, networking, energy, and cooling capabilities. Often, the sheer number of GPUs necessary for AI use case also requires far more square footage. GPUs are just bigger. There's the cooling and all the other things as well to consider. Hyperscale versus colocation. Hyperscale and colocation describe two types of data centers commonly used by organizations for AI. Hyperscale data centers are huge, these are the ones that we've been following and reading about and learning about. These are the big ones from Google, Amazon, Microsoft, companies of that nature, including at least 5,000 servers and occupying at least 10,000 square feet of physical space. They provide extreme scalability and capabilities and are engineered for large-scale workloads such as generative AI. They are in wide use globally by cloud providers such as Amazon Web Services, Microsoft Azure, Google Cloud Platform for various purposes that include artificial intelligence, automation, data analytics, data storage, data processing, and more. A colocation data center refers to a situation where the company owns a hyperscale data center and rents out its facilities, servers, and bandwidth to other companies, just like XAI leasing out their uh, Colossus One data center to Anthropic. This setup allows businesses to enjoy the benefit of hyperscale without the major investment. Some of the world's biggest users of colocation services are Amazon, Google, and Microsoft. For example, these cloud service providers lease significant data center space from a data center operator called Equinix. They make their newly acquired space available to customers, renting it out to other businesses. Okay, so that's why when we were following data centers, it's not Amazon themselves building it. They hire other companies, or other companies come and lease and build it, and those companies are the ones that partner with the local officials and all that. They build it and then they lease it. The growth of AI data centers. In an early 2025 blog post, Microsoft named AI the electricity of our age. Whether that declaration is hyperbole or spot on remains to be seen. However, the adoption of AI tools such as OpenAI's ChatGPT by millions of non-expert users has moved at an electrifying pace. This clear productivity and monetization potential of AI capabilities has led to an intense flow of new AI productivity tools, agents, and content generators. Open source models and the continued democratization of AI means it's not just major players making waves in the AI ecosystem. Almost any entity can be a tech company if they can identify an AI use case and adopt the IT infrastructure to get it done. According to a 2024 report by IBM Institute for Business Value, IBM IBV, 43% of C-level technology executives say their concerns about their technology infrastructure have increased over the past 6 months because of generative AI, and they are now focused on optimizing their infrastructure for scaling it. Meanwhile, the data center industry has grown to fit demand. Data center infrastructure around the globe is increasingly AI ready, capable of processing high volumes of complicated computation and requests. Currently, the Asian Pacific and North American regions have the highest proliferation of data centers, particularly in areas such as Beijing, Shanghai, Northern Virginia, and San Francisco Bay Area. Those are the ones, if you guys remember, in our past videos, these are the hotspots that we've been following, especially Northern Virginia and China. I think we learned about one or two San Francisco Bay Area data centers, but I'm not sure. I don't remember exactly if we saw any. But Northern Virginia, because they give very good tax breaks to data centers, and for something like 20 years, a data center doesn't need to pay any tax or anything in Northern Virginia just to operate there. So that makes it a very good spot for these companies to come and build their data centers. Substantial investments from big tech have also signaled growth for the AI data center sector. In 2025, Microsoft plans to invest approximately 80 billion USD on data center construction, and Meta is investing USD 10 billion in a new 4 million square foot hyperscale data center development in the US state of Louisiana. Key features of an AI ready data center. Okay, so this is what you would need to run an AI ready data center: high performance computing, advanced storage architecture, resilient and secure networking, adequate power and cooling solution. High performance computing. An AI ready data center needs high performance computing, HPC, such as those found within AI accelerators. AI accelerators are AI chips used to speed up machine learning and deep learning models, natural language processing, and other artificial intelligence operations. They are widely considered to be the hardware making AI and its applications possible. GPUs, for example, are a type of AI accelerator Popularized by NVIDIA, GPUs are electronic circuits that break complicated problems into smaller pieces that can be solved concurrently, a methodology known as parallel processing. HPC, high performance computing, uses a type of parallel processing known as massively parallel processing, which employs tens of thousands of millions of processors or processor cores. This capability makes GPUs incredibly fast and efficient. AI models train and run on data center GPUs, powering many leading AI applications. Increasingly, AI ready data centers also include more specialized AI accelerators, such as neural processing units, NPUs, and tensor processing units, TPUs. NPUs mimic the neural pathways of the human brain for better processing of AI workloads in real time. TPUs are accelerators that have been custom built to speed tensor computations in AI workloads. Their high throughput and low latency makes them ideal for many AI and deep learning applications. Advanced storage architecture. The velocity and high computational needs of AI workloads require vast data storage with high speed memory. God fucking damn it. This is why freaking RAM and SSDs are fucking up, man. Fuck. Fuck. What if they didn't need that? Fuck, man. Fuck. It was one thing when the GPUs were expensive, but now it's like every fucking piece of a computer is expensive nowadays, dude. Jesus, man. Solid state drives, SSDs, semiconductor based storage devices, which typically use NAND flash memory, are considered critical storage devices for AI data centers. Specifically, NVMe SSDs, which have the speed, programmability, and capacity to handle parallel processing. Data center GPUs, accelerators, and some SSDs also use high bandwidth memory, HBM. This type of memory architecture enables high performance data transfer with lower power consumption than dynamic random access memory, DRAM, a more traditional memory architecture. Another typical facet of AI data center design is data storage architecture that can accommodate fluctuations in data demands, such as unexpected surges. Instead of running workloads on dedicated hardware, many data centers, both AI and conventional, use a cloud architecture where physical storage is virtualized. That's very interesting. I don't think I knew about that. Virtualization is the division of a single computer's hardware components, such as memory and storage, into multiple virtual machines. It enables better resource usage and flexibility by allowing users to run multiple applications and operating systems on the same physical hardware. Virtualization is also the technology that drives hybrid cloud capabilities. Hybrid cloud gives organizations increased agility and flexibility to connect cloud and on-premises environments, which is critical for adopting data-intensive generative AI. Resilient and secure networking. AI must be fast. Users expect instant responses from online AI applications, and autonomous vehicles need to make split-second decisions on the road. Therefore, AI data center networking must be able to support high bandwidth requirements of AI workloads with low latency. For hyperscale data centers, bandwidth requirements can range from several gigabits per second to terabits per second. That's pretty fucking fast. I'm not gonna lie. My current internet speed is 2 gigabit per second. I can't imagine a 1 terabit per second at all. Wow, that's gotta be lightning fast. Traditional data centers use fiber optics for their external communications network, but the racks in data centers still predominantly run communications on copper-based electrical wires. Co-packaged optics, a new process from IBM research, promises to improve energy efficiency and boost bandwidth by bringing optical link connections inside devices and within walls of data centers used to train and deploy large language models. This innovation might significantly increase the bandwidth of data center communications, accelerating AI processing. Almost all modern data centers use virtualized network services. This capability enables the creation of software defined overlay networks built on top of the network's physical infrastructure. It allows for the optimization of compute, storage, and networking for each application and workload without having to make physical changes to the infrastructure. AI data centers require cutting edge network virtualization technology with better interconnection, scalability, and performance. It must also be able to address data privacy and security concerns related to the large volume of data used to train generative AI models. In an IBM IBV survey, 57% of CEOs say concerns about data security will be a barrier to adopting generative AI. And lastly, you need to cool your data center. The high computational power, advanced networking, and vast storage systems in AI data centers require massive amounts of electrical power and advanced cooling systems to avoid outages, downtime, and overload. Goldman Sachs anticipates that AI will drive a 165% increase in data center electricity demand by 2030, which we've been covering all the data center demands in these past videos. So check out our other videos if you want to see a more deep and detailed breakdown of how much a hyperscale data center uses electricity. And McKinsey's analysis suggests that an annual global demand for data center capacity might reach 171 to 219 gigawatts. The current demand is 60 gigawatts. So at least holy Jesus, at least 3 to 4 times more. Fuck. By 2030, 3 to 4 times more. To meet these intense energy consumption and cooling requirements, some AI data centers employ a high density setup. This strategy maximizes data center square footage with compact server configurations that perform better and are more energy efficient and contain advanced cooling systems. For example, liquid cooling often uses water rather than air cooling to transfer and dissipate heat. It offers greater efficiency in handling high density heat and improved power usage effectiveness, a metric used to measure data center energy efficiency. And another cooling method, hot and or cold aisle cooling containment, organizes server racks to optimize airflow and minimize the mixing of hot and cold air. Given these significant power requirements, today's organizations often seek a balance between their AI ambitions and sustainability goals. No, they're not. No, they're not, man. No, they're not. Only Apple is. The one impressive example comes from Apple. That's the only impressive example. I don't think they care about us, especially with the regulations and the red tapes just coming off left and right. So yeah, they don't care, man. IBM, you don't need to pretend. You don't need to pretend. One impressive example comes from Apple, one of the world's largest owners of hyperscale data centers. Since 2014, all of Apple's data centers have run completely on renewable energy through various combinations of biogas fuel cells, hydropower, solar power, and wind power. Others are looking toward extraterrestrial energy sources, hoping to take advantage of the high intensity solar power in space to build new data centers. Breakthroughs in orbital data centers might lower energy costs considerably for AI training models, potentially cutting power expenses by as much as 95%, cutting power expenses for the data center, not for you puny humans. You will pay. The data centers are going to jack up the price, then they're going to take them to space, so their costs are down, but you still have to pay the jacked up price. It's just the way it works, man. It's smart business. It's smart business, man. Congratulations to all the data center owners. All right. So we learned that in a data center, you need high performance computing, advanced storage architecture, resilient and secure networking, and adequate and power and cooling solutions. So all these four put together gives you a nice hyperscale data center that can run, train, and deploy AI. Again, I want to learn even more exactly what each of these contain as far as hardware parts, just so that we can see, okay, a single data center has this, and that hardware. But that might need to come at another time, because this is more of an overview article. And then if I find something that is more detailed as far as like what exactly is the hardware inside it, we're gonna look into that. But as far as an overview and a macro look at hyperscale data centers, this was really good. And it explained everything relatively simply. All right. This is Good Morning America, ABC News Live, inside Google's AI data centers. All right, are we ready? Let's get to it.
Now to the AI revolution. Big tech companies are spending billions of dollars to build data centers around the country to power AI, but public backlash to these massive facilities is growing, and many Americans don't know how this critical infrastructure actually works. ABC's Elizabeth Schulze got exclusive access to one of Google's data centers in Alabama as the tech giant pulls back the curtain on its operations.
In the foothills of the Appalachian Mountains in Alabama, where a former coal plant once roared,
all of these lines came out of that old coal plant.
Now a different kind of hum from a sprawling Google AI data center.
How big is this site?
So the property is just over 600 acres.
600 acres.
It's a fairly large.
How big is this site when you're driving in it with a fucking caddy, dude? How big you think it is, lady?
Property. We've only developed less than a quarter of it so far.
Amid growing pushback against the rapid build-out of data centers nationwide,
There's been remarkably fast backlash to building out these data centers.
It has surprised me a bit.
Google is pulling back the curtain. Site manager Thomas Gamble gives us a rare exclusive look at the campus, including its high-security server room.
Here we go, going in.
Security here so tight, it took 6 stages and a full facial scan to get in.
You're good to go. We're in.
And the room is so loud, we need earplugs.
Good.
If you think about when you first turn on a computer and start it up and you hear that noise, that's what you're hearing right now.
This is like out of sci-fi.
Inside, we
I gotta be honest, man. If your computer is sounding like that, dude, you got big problems. If you turn on your computer and it sounds like that, that is not. It's not the same thing at all, lady. It's not the same thing. Nope, dude. You've got big issues. You gotta tear your computer apart if your computer is sounding like that, dude. It's freaking crazy.
see thousands of advanced computer chips that are stored in trays and racks, processing information 24/7.
So if you're looking at your Gmail or your YouTube videos or you're pulling up maps, all of that is getting processed on these servers right here and sent through these networking cables out to you on your device.
The actual internet is running right here.
It is running right here. We do all of Google's services. We do important services for hospitals and 911 call centers. We're processing all of that information and sending it out to users right here.
These servers running nonstop can overheat. We see pipes filled with cold water to keep the room cool.
Does it not work if it's too hot?
Components can fail if they get too hot.
Once we step outside, the noise is hard to hear. Then we follow the massive pipes across the campus to a row of 10 towers where the water is cooled.
We're gonna go up here?
Yep.
Giant fans draw air across cooling towers where evaporation helps chill the water before it's pumped through the pipes.
When people see data centers, they see what looks like pollution, emissions. What this is...
This is the same water that comes from the facility that goes to everyone's home in the community. It's treated water. We're just using it as a cooling medium.
water vapor, not
We're using water.
emissions.
I'm trying to be fair to these data centers, right? I'm not trying to paint them as evil. I'm not trying to say like across the board everybody that works at a data center is a horrible person and all that. Like no. Like, you know, they're doing their jobs and that's their specialty, and they couldn't have foreseen this backlash that people are having against AI and all that. But when you say this is the same water as regular people use, aren't you saying that, hey, we're taking your water and just cooling computers with it? Like, isn't that bad? Like, I'm just, the guy's acting like it's no big deal. And the lady's like, yeah, people saying it pollutes. No, it doesn't pollute. We're just gonna take your water and cool with it. Yeah, what's gonna happen after you cool that water, dude? It's not gonna be safe for consumption anymore. After you cool the computer, it's gonna be just hot ass water that you're gonna just dump. What was it? The data center in Utah, right? You were reading about a data center in Utah where Amazon was drawing water and cooling their data centers with it. However, already that water was a little sus because of the farmland, and there was like a lot of nitrate in the water, but it's still the levels were okay. It wasn't nothing too crazy. But once Amazon would use that water to cool their data centers, because of the evaporation, the levels of nitrate would just skyrocket in the water. Yeah, Amazon wasn't at fault for putting nitrate in the water, but at the same time, they were at fault for accelerating that process and making the situation worse, so that nobody could use that water. That water was not drinkable anymore. So for you to come around and say, "Oh, we're just doing some regular. You use this water to drink it. We use it to cool our data center." Number one, people who drink that water use a cup. You're using thousands of gallons per data center. And number two, you're not polluting the water, but you're still not cleaning the water. You're not recycling the water as much as you should, and you're just using the water and just dump it somewhere else. So if for you to come back and be like, "Oh, we're not at fault and everything's above board," is I don't know. Maybe disingenuous is a little bit harsh, but it's still not honest. It's not dishonest, but it's not honest.
Warm water coming out, cool water back in, recycled at least 7 times.
How do you make sure when it's a really hot day you're using only your water and not the neighborhoods?
But we have meters, so we've got agreements with them.
Well, they should just say we use the same water as the regular people. Hold up.
Data centers,
Giant fans draw air across cooling towers where evaporation helps chill the water before it's pumped through the pipes.
when people see data centers, they see what looks like pollution, emissions. What this is
This is the same water that comes from the facility that goes to everyone's home in the community.
This is the same water from the facility that goes to everyone's homes in the community. So you're using the community's water. It's not like a special water just for you, dude. So for you to come around and be like, we're not using the community's water and it's all metered, it's which one is it then?
Treated water. We're just using it as a cooling medium.
water vapor, not
We're using water.
emissions.
Warm water coming out, cool water back in, recycled at least 7 times.
How do you make sure when it's a really hot day you're using only your water and not the neighborhoods?
But we have meters, so we've got agreements with them on how much water we can or can't use that dictates what load we have.
Yeah, the agreements from the crooked local officials that bend over backwards for Google's money. Sure, dude. Those are very honest and above board agreements. Sure, man. Sure. Agreements where it takes 90 seconds for them to decide to have a data center, have them use all the power available and all the water available. It takes them like that to decide on that, and that's all above board and all okay. Like, come on, bro. Let's get real, man.
This data center's been up and running since 2019.
It's an active construction site.
And this week, Google announced a $1.5 billion expansion.
So this construction right now is to expand the data center even more.
Yes. We're looking to add future buildings on this campus to meet the growing customer demand and the needs of our users.
A move the company says will bring in 1,000 temporary construction jobs.
A lot of people say these data centers bring jobs, but only for a short time when they're building, and then not that many people actually work here.
No, there's always an influx of jobs for construction. Anytime you build anything, you're going to have a larger influx for construction. But I will say here at Google, we have a significant amount of jobs we've brought to the community.
In your view, this adds jobs.
Is it just me, or is this guy just not answering the questions? Why like...
A lot of people say these data centers bring jobs, but only for a short time when they're building, and then not that many people actually work here.
A lot of people say these data centers bring a lot of jobs, but just when you're building, and then after that, not that many people work here. That's what she's saying. She's saying these jobs are only available for a short period of time because they're construction jobs, and once the construction is done, which ideally for Google, they want the construction to be done as soon as possible. So like how long you're gonna have a job, like a year and a half at the most. Then after that, the jobs inside the data centers are not that many, which we have read, check out our other videos, on data centers where these huge, giant campuses are run by like 100 people. They're saying they bring 1,000 jobs over, but then after the construction is done, it's you literally only employ 10% of the workforce that you had. After all the data centers are built, then what, right? That's what I'm wondering. After all the data centers are built, are you gonna have as many jobs available as you did when they were being built? No, obviously not. And if anything, there was we were reading about the jobs in data centers. It's a lot of it is not even direct hires by Google. It's third-party companies that'll hire people to run these data centers, and Google just hires the company. So you don't even get benefits of being a Googler. You don't have the benefits of being employed by Google. So for Google saying we're bringing jobs, it's a little bit of again, it's short-term jobs, and after that you're not hiring that many people. So what's the what after that? Well, what's going to happen 5 years from now when all the data centers are built?
No, there's always an influx of jobs for construction. Anytime you build anything, you're going to have a larger influx for construction.
Well, he didn't answer. There's always an influx of jobs for constructions. Yeah, but after the construction's over, Google doesn't hire that many people. Why is that?
But I will say here at Google, we have a significant amount of jobs we've brought to the community.
In your view, this
They
adds
just
jobs
skipped over
versus
it.
takes them away.
This does add jobs. I mean, and this site where we're at, the previous coal facility was on the same property. And when that closed, that was a lot of jobs that left this community that we've been able to come back and replace all those jobs plus more.
As tech
Shut the fuck up. I don't believe that at all, bro. I don't believe that at all because you didn't answer the original question. Yeah, this adds more jobs, temporary. Again, temporary jobs. And then after the construction is over, you have a data center that is actively working to take away more jobs. These data centers are not here to help regular people. They're here for corporations to improve their efficiency and save money, and for them to be able to save money on labor costs, most importantly. So the end goal here is to have the least amount of jobs. So for him to come back and say, no, we're employing even more people than before, and they always go back and like, oh, this used to be a coal plant, and then when the coal plant closed, all the jobs were lost. Yeah, dude, isn't that what happens when the AI takes over and all the jobs are going to be lost because of AI? Wouldn't that be the same thing?
giants race to build the infrastructure to power the AI boom. Recent Gallup polling shows 71% of Americans oppose the construction of AI data centers in their areas, citing concerns over strained resources, noise, and higher utility bills. In town halls across the country, our team has witnessed frustration and outrage over the rapid build-out of these data centers to power AI.
People are getting steamrolled.
At least 14 states have now proposed a pause on new data center sites.
We see across the country, there's so much negativity, concern about these data centers on people's bills, on water, just on it coming into the community.
There's a lot of negative sentiments as we're building. We're trying to figure out the best, most efficient use of all the power, the water, any of the systems we can.
Gamble shows us how this site has built its own power.
Bro, this guy's not even answering anything. The lady says there's a lot of negativity, and then the guy says there is a lot of negativity. Okay. Come on, man.
Substation.
This puts us on an island separate of the rest.
Ensuring Google pays for all of the massive amounts of electricity used here, instead of having neighbors foot the bill, a pledge the company has made nationwide.
The best analogy about a data center is we're just a lot of servers that's storing information just like books are in your library.
People do not think of data centers like public.
Yeah, dude. The books are in your library. The books in your library don't require constant electricity. Don't jack up the price of SSDs and RAMs. And the worst the books in your library can do is consume trees, a renewable resource that you can plant and grow And from one tree, you can get like a bajillion books. But you need enormous amounts of energy and material to get the data centers built. It's not the same. Thank God, at least she said it's not the same thing.
Libraries right now.
But it's just a very large public library because we're organizing the world's information and making the systems operate.
What? Wow, bro. Wow. They gotta get a better guy to do PR, man. This guy sucks ass. He didn't answer any question and just gave the worst analogy of all time. That even the reporter that was glazing him and Google just had to push back and be like, oh, this is not the same thing as libraries, bro. Anyways, man. Anyways, at least we learned a little bit about what goes on in the data center. They showed a little bit inside of it, and hopefully we get to know more about what's inside data centers. And yeah, we're going to be following data center constructions all across the globe, all across the country. Please like and subscribe for more data center reports. And let me know in the comments what else you want me to talk about. If you got any updates on any data centers that you want me to look into, any sort of interesting news and interesting development that's happening, let me know. We are 100% dedicated on this channel to following data centers and seeing where this goes. Thank you everybody for watching, and I will see you guys next time. Radio out.